Okay. A radian is an angle measure that has a lot to do with the radius. Does that make sense? Radian, radius? By definition, a radian is a central angle of a circle whose measure cuts off an arc with the same length as the radius of the circle. We define a radian to be an angle whose measure cuts off an arc equal to the length of the radius of the circle. So like I said, radian is a measure that has a lot to do with the radius of a circle. Here is the radius of the circle I've got labeled with this blue R in the figure. From the center to the edge of the circle. Let's call that length R for the radius. Then the angle that cuts off the same length for an arc of the circle is defined to have a measure of equal to 1 radian. Because this blue length, the radius of the circle, is equal to this arc measure for the circle, the angle that cuts off the same arc has a measure that's equal to 1 radian. Does that make sense? This length and this arc length are the same. Arc length is equal to the length of the radius of the circle. So the angle that cuts off the length of the arc equal to the length of the radius has a measure of 1 radian.
Should we start to find?
So let's talk about how I can convert back and forth between radians and degrees. Let me give you some common angle measures in degrees. How many degrees are around a full circle? 360. So let's talk about what that would be in radians. How many radiuses go around a full circle? What is 360 degrees in radians? Let's look at the link up on the television screen here. And we'll think about how many different radiuses it takes to wrap around a circle. Okay. So up on the television screen, I've got kind of this link to help us investigate more. I want to know what a full circle in degrees would be if I measured in radians. I know 360 degrees is all the way around a circle. What does that measure in radians? So here on the link, this circle has a length of the radius measured from here to here. That's a length of how much? 3. Now this blue line, I'm going to start wrapping around this circle. Every length between 2 yellow dots is the same length of 3 that is given from the radius. The radius is a length of 3. I go up 1, 2, 3 to find the next yellow dot. That's also a length of 3. I go up 1, 2, 3 more. That's also a length of 3 equal to the radius of the circle. So how many different radiuses, how many different dot to yellow dot lengths can I wrap around the circle? So let's start sliding this around. Okay, there's about 1 radian. There's 1 radian. Because I've got from here to here wrapped around the circle. Here to here wrapped around the circle. That's the same length of the radius of 3 given from the circle itself. How many different times around the circle? How many different radiuses can I wrap around the circle? Close. 6. I heard 6. I heard 6.5.
7.
7's a little bit too much. It's between 6 and 6.5.
6.35.
6.3 is pretty close.
6.325.
Getting a little bit further away.
6.2.
Close.
6.267.
6.1.
So I have it there. A little bit more. About 6.28.
Oh, I think 7.
it takes how many different radiuses to wrap around a full circle?
6.
A little over 6.
Oh, that's 6. So 365.
About 6.28. In terms of pi, what would 6.28 be equal to? How many pi's are there in 6.28? For the same matter?
2.
2. It takes 2 pi radiuses to wrap around the circle. But you already knew that. What's the formula for the length around a circle? The circle. That's the area, Maddie. What's the formula for the circumference? The circumference of a circle is 2 pi r. So to go around the circle, to wrap around the circle, how many different radiuses do we need? We need 2 pi of them. Because isn't 2 pi about 6.28?
Yes.
3.14 twice is 6.28. If a radian is how many radiuses, if a radian measure is an angle equal to how many radiuses are wrapped around the circle, how many radians is 360 degrees equal to? All the way around the circle is how many different radiuses?
6.2.
Or in terms of pi, Trey, that's
2 big.
a radian is an angle measure equal to how many different radiuses that the arc the angle creates cuts off. So all the way around the circle is 360 degrees. How many radiuses then? Well, to go around the circumference of a circle, it takes 2 pi radiuses. So in radians, 2 pi radians is the same as 360 degrees. Have I kind of made the connection there for you?
It's pretty.
So if 360 degrees is 2 pi radians, how about a semicircle?
Go.
What would 180 degrees be the same as?
5.
So 3.4.
Or in terms of pi, as an exact value, Trey, which is pi radians. 180 degrees, an arc measure of a semicircle, is equivalent to 1 pi radians because it's just half of the full circle, 2 pi radians. Converting back and forth, between radians and degrees can be done using a simple conversion factor based off the fact that 180 degrees is equal to 1 pi radians. To radians, we multiply our angle measure by pi over 180 degrees. 1 pi radians and 180 degrees are the same thing. So when I divide the two, I'm really just multiplying by a factor of 1. I'm not changing the angle measure because I'm multiplying by a factor of 1. I'm converting it from one angle measure to the other, from degrees to radians. Okay, what if I want to go from radians to degrees? To go from degrees to radians, I multiply by pi radians over 180 degrees. To go from radians to degrees, I just do the opposite. Okay. Explain that one more time, why this conversion factor works. I've shown you that 180 degrees and 1 pi radians are the same angle measure, right? So when I divide the two, I'm basically just taking the same thing divided by itself, so it's really just 1. I'm not changing the angle measure, I'm just converting from radians to degrees, or vice versa, as I use these two different conversion factors. So for a quick example here, convert each measure from degrees to radians, or if it's in radians, convert it back to degrees. DEG is short for degrees, and RAD is the abbreviation for radians, measure in radians. I have an angle measure that's equal to 5 pi over 6 radians. We label it in terms of radians. It's a radian measure in terms of pi. Typically, radian measures are in terms of pi because (360 degrees is 2 pi radians, 180 degrees in pi radians. Radian measure are in terms of pi since it's based off the circumference. So if it's in radians, I want to convert it to what? Degrees. So we have the conversion factor in order to do that. I want to go from radians to degrees and multiply my angle measure by 180 degrees over pi. 5 pi over 6 times 180 degrees over pi radians. What happens to the pi's?
Cancel out.
Cancel out. Which should make sense, right? Don't I want to cancel out radians and turn it back into degrees? I want to get rid of the pi, put the pi on the bottom. So it cancels out the other pi from the angle. 5 times 180, divide that by 6, according to my conversion factor. What's 5 times 180 divided by 6?
150.
150.
Yeah.
So what have we now shown? 150 degrees is equivalent to what angle measure in radians?
5 pi over 6.
Pi over 6. 150 degrees is the same as 5 pi over 6 radians for the same angle. Well, we try 45 degrees. Okay, how's this question different?
You don't have a bottom thing, so you probably have to put it over.
Not necessarily. What is my angle measure given now, though, Hallie? It's degrees. I want to convert it to
Yeah.
radians. Rather than taking it from radians to degrees, let's take it from degrees to a radian measure in terms of pi. So to go from degrees to radians, I just multiply by the reciprocal of that same conversion factor I used previously. So rather than multiply by 180 over pi to go from radians to degrees, to do the opposite, multiply by pi over 180. It helps to put 45 over 1 so you know what to multiply together on top and bottom. Good. I want to answer in terms of pi. So let's just multiply the rest. 45 times pi on top would be 45 pi. 1 times 180 on bottom is obviously just 180.
Reduce.
Reduce. Obviously, 45 and 180 is not in simple terms. What do you think, Michael? What can I divide 45 and 180 by? At least 5? How about we get there a little bit higher? Want to try 15? 45 divided by 15 would be 3. How about we try 3 pi? What's 180 divided by 15? 12. You say, Stephen, is 3 pi over 12 in simplest terms? Yeah. So I can divide both by 3?
Yep.
3 pi divided by 3 is 1 pi. 12 divided by 3 would be 4. What have we just shown? What is 45 degrees the same as if I were to measure it in radians?
Pi divided by 4.
Pi over 4 radians. Pi over 4 radians. Let's do what we have. It's about 2 radians. What is my angle measure given in by now? What's this measure? Radians. I want to convert it to degrees. Well, here's the same conversion factor we used earlier. To go from radians to degrees, multiply it by 180 over pi. So take 2 radians, or just take 2, multiply by 180 degrees over pi. It helps. Put 2 over 1 and just multiply it together. What's 2 times 180, obviously?
360.
360. What's 1 times pi?
5.
Let's reduce this down. 2 radians is what approximately when it comes to a decimal. What's 360 divided by 3.14? Or 360 divided by pi? So again, right? 114? We said? 114 point what though? There's 3 more to it.
5, 9, 6, 4,
6, 4, how about 6, 5 then?
9.
Let me check that on my calculator here. So we know we got it. We had 360 divided by pi, about 114.6. Something close to that would be fine. Depending on if you use 3.14 or a stored version of pi on your calculator. You guys try these ones. Okay, put 3 on the board. I'd like you guys to convert back and forth between the two. This is something we're going to have to know how to do before we can talk about arc length and sector area using radian measure. 7 pi over 4 is in terms of what? Is that radians or degrees? Radians, you got to convert it to degrees. 120 degrees, convert that to radians. And 5 radians, convert that back to degrees. Convert those 3. AJ, how you coming here? Can I get you started on something?